here in this class, actually, I will take 19 classes, or it may be slightly more also. The part which I will cover for this embedded system design is the hardware part, basically, and the software part and other means programming part you will other teachers will take. Then and software this hardware part for embedded system design I want to discuss. This part will cover the basic hardware components and the closed loop systems, embedded systems, and then I will cover different types of uh, sensors which can be used for designing embedded systems. Not in details, but I will give the names and a brief of these sensors, basic principles only. So details can be taught in the sensor design class, but here it is not possible. And then I will discuss on the sample and hold circuit, sampling theorem and sample and hold circuit, which will be used for designing the embedded systems. Now, actually, the performance or characteristics of the embedded system is dependent on both hardware and software. Okay. So what will be the speed of embedded system, whether noise is captured by the system or not? Uh, what are the controllable parameters? All these things are actually discussed in the hardware part. Now it is very difficult. What I want to say, though I want to discuss about the hardware part of the embedded system. So there are different types of embedded system. For all these types of embedded systems, unique hardware is not possible. Just for the hardware systems or a closed loop system, which I will try to discuss here, that is very common to many types of systems. I want to say not for all, but this kind of closed loop systems are very common in many applications. That's why I will cover that particular type of embedded system hardware. Okay, and the associated components used for that kind of hardware. So, yes, is there any problem? Okay. Now, at the end of this lecture, what you will get the embedded hardware in a loop form. Then I will discuss on some of essential components found in most of the embedded systems hardware. Then brief of sensors used for the most of the embedded systems. I will try to discuss this part in this class. And then I will go to the sample and hold circuit and sampling theorem. Okay, anyway. This is the most important thing already mentioned, that the development of ES, embedded system, cannot ignore the underlying hardware characteristics, because timing, memory usage, power consumption, and physical failures, these are the very important things, and the hardware will confirm, okay, these parts. So we should consider both hardware and software, okay, because the efficiency is important thing. So the efficiency can be improved by designing the hardware system properly along with the software this design of software. Energy utilization is also another factor. Reliability is another factor. Actually energy means actually for most of the hardware systems, what we want that less amount of power or energy should be used for the embedded system. That means if I can use a 3-volt battery, for example, for an embedded system, then it will be better for us. That is, the system should consume lesser amount of power or energy. That will be this will be actually useful for us, and the hardware should be reliable. Okay, so these are the common points which can be offered by hardware systems along with the softwares. Now, next part is what I mentioned already, that hardware for embedded system is not standardized like personal computers. I cannot say that these are the basic components used for all types of embedded systems. We have a large variety of embedded systems hardware. So it is not possible for us to provide any comprehensive overview for all types of hardware, for all types of embedded systems. Okay, but what I want to say that I can think of a system like this, for example, a closed loop system like this, which is generally used for many kinds of many types of embedded systems. That's why I want to discuss closed loop block diagram and closed loop systems like this, where I have shown here. It is a closed loop system, and the basic blocks or basic circuits, basic hardware components which are used for these closed loop systems I will discuss, and you will see that most of the embedded system will use all these things. Here in this embedded system, what I want to say that this is environment. This is a closed loop systems. Okay. This environment can be sensed by the sensor. I will discuss different types of sensors which can sense the environment. And this sensor, after sensing the environment, it will generate some analog signal, analog electrical signal, which is continuous in time and also which is continuous in amplitude also. Okay. So if we want to develop some embedded system in digital that can process the information digitally, then obviously one component or one block should be there which can sample the analog signal, and then it will be converted to digital for the further processing. Okay. So here, this AD converter sample and hold. This is the block where the sample and hold circuit will sample the sensor output. Okay, it will take the analog signal from the sensor output, and then the signal will be sampled. And this sampled signal or sampled values should be converted to a digital number by using analog to digital converter. I think in third semester or fourth semester you have studied about this in digital systems or digital. On one paper was there, most probably digital systems like that, and digital logic systems. In that paper, most probably this AD converter is actually discussed. Okay, so I think though I will discuss here, I think you have some idea about analog to digital converter. In analog to digital converter, each and every sample value which is not discretized or which is not actually converted or quantized by using any circuit, that value may be actually real number. For example, for a particular time instant, the sample value which you have obtained from this sample and hold circuit, the value of voltage or current which you have got, for example, you have got voltage. This voltage is, for example, your 5.2 value. So, or 5.33 value. This 5.33 value, this is very difficult to store in the memory location. Why? Because if you want to convert this 5.33, then this integer part is okay, but for the fractional part 0.33, is it possible to is it possible to represent this 0.33 by using finite number of bits? No, I think it is not possible, because some recursion will means happen at the time of conversion. Okay, and the number of bits which will require to represent this 0.33 part, that will be infinite. So what you have to do, if you want to store this particular value 5.33 in the memory location, you don't have the memory location with infinite size. Therefore, you have to forcefully limit the number of bits. If you forcefully limit the number of bits, automatically that cannot be means that cannot represent the 5.33 value in exact form. It will be it may be like this 5.32 or something like that. It will be lesser because you have truncated the number of bits, and that is actually quantization. Okay. Anyway, this AD converter will perform that. You know, different types of AD converter are there. Different types of AD converters are there in practice. I will discuss one or two of these AD converters for you this class. For this class. Okay, so this AD converter function is this. It will convert the real values which is obtained from the output of the sample and hold circuit into a binary format or digital format. And this digital information, actually the sensor output in digital form. Okay. This information will be processed by this information processing unit, and here in information processing unit you can develop different types of software for processing it properly. Okay. So another you can use some softwares, you can use some hardware also for processing. Some noise may be there in the input signal. Means output of the AD converter may contain some amount of noise, and this noise can be removed here in the information processing section by using some type of filtering system technique. Anyway, after processing the information, either you can display the information, or you can again convert this into analog, because here you see this environment here is simulated by actuators. So this actuator works on the principle of analog signal, and therefore the input of the actuator should be analog in nature. Therefore, directly the output of the information processing unit cannot be sent to the actuator. Okay, because actuator will be actuated based on the analog signals at the input of the actuator. Okay, therefore one output of the information processing unit, you can send it into display for displaying the information. Okay, and other output of the other input of the display, maybe here the output of the AD converter, you can display the analog output of the analog form also. You can see the information in analog form also. That's why the output of the one output of the DA converter is applied to the input of the display unit. Actually, in the display unit, what you can see, you may want to display, get the information in the display unit in the form of digital signal, or you can get it in the form of analog signal. For example, if the display unit is here like this, analog CRT, analog CRT means, you know, cathode ray oscilloscope like type of thing. Then the input which should be supplied to the input of the this CRT, it will be analog in nature. That's why here the display unit is not mentioned whether it is digital display or analog display. If it is analog display, therefore in that case actually the analog output will be given to the input of the display. That's why here this output of DA converter is applied to the input of the display unit. But if the display unit is digital, then you can directly send the output of the information processing unit to the input of the display for displaying the information in digital format. Okay, and here the actuators will be actuated by this by the output of the DA converter, and then it will change the again. It will actuate the influence the parameters of the environment. So this is one kind of closed loop automatic control system that can be realized by using embedded hardware design. Okay, so these are the basic things, basic blocks or basic elements which are mostly required in designing embedded systems. Okay, now next, actually, examples. I want to give some examples of this kind of where this kind of automatic control system is used. One of them is the automatic heater, heating control. Okay, the environment means here the temperature of the water can be sensed by a sensor. Then this output should come to the controlling that should be sampled. Then it will be processed. Then it will be checked. After checking, if some decision we have which we need to take, then I will send this information to the actuator unit, and the actuator again it will control the temperature of the heater. Similarly, engine control of a car, there also you can use this kind of control systems. Power grids, in robotic control, you can use this kind of control systems. Okay, so here you see, this is the most important thing, this sensor. The different types of sensors used for different applications for different purposes. A sensor will sense the environment parameters. Okay, so here we will see that different types of sensor we have for sensing the physical quantities like weight, velocity, acceleration, electric current, voltage, temperature, chemical things, chemical materials, etc. and etc. So for chemical materials, chemical sensors will be used. Okay, so different types of physical quantities are there which we can sense, and then the sense means actually the sensor will sense the physical variable or physical quantities that may not be always electrical, in the form of electrical. However, the sensor will sense that particular physical variable or physical quantity, and then the sensor will convert this into electrical form. Sometimes, for example, some pressure can be sensed by pressure sensor, and then the sensor will generate a corresponding electrical signal which will indicate the change of the variation of the change of the pressure in the environment. Okay, so the pressure can be sensed, the velocity can be sensed, acceleration can be sensed, the electrical current, electrical voltage, temperature, this can be sensed by sensors, chemical things. Okay. Now I want to discuss different types of sensors. Before that, I want to mention some important things. Actually, I want to say important specifications for sensor. When you will go for purchasing the sensor, then what you will say to the shopkeeper? You should mention something. Actually, if you want to go to purchase, for example, a camera, then what you should say there? That you should ask that what type of you should say what type of camera you want to purchase, what should be its resolution, what should be its the megapixels, etc. and etc. What should be the dynamic range, what should be the noise produced by the camera. So all these things are basic specifications. That means here, if the resolution is higher, then obviously the sensor will be good. But it may be that if you want higher resolution, a sensor with higher resolution, the cost will be also more. Therefore, based on your application, you will choose a proper sensor with proper specification. Similarly, sensitivity. Sensitivity also another factor, another specification which should be mentioned at the time of purchasing the sensor. So if the sensitivity is high, then it is also better for your applications. But sensitivity better means it may be that the cost will be more. So all these are the specifications. Whenever you will try to purchase some sensor, then you should mention the specifications that I want this amount of resolution, this amount of sensitivity, this amount of dynamic range. It should be linear. Linearity should be high. There should not be non-linearity part of any uh, means input-output relationship, and it should be noise-free. Actually, whatever signal will be produced by the sensor at the output after sensing the physical quantity, that should be noise-free. So all these things you should mention. So it may not be always noise-free, but the amount of noise should be very less. You should mention what you want.
Sir?
Yes.
So what should the linearity be, sir?
Linearity means actually input-output relationship should be linear. Means output should change in a linear manner with respect to the input. Means y is equal to mx in this form. Y is the output, x is the input. Y should vary in accordance with the input. Okay. Then the performance of the sensor will be better. The response is linear. Okay. If you increase the input signal 2 times, then the output input pressure 2 times. For example, for a pressure sensor, if you increase the if you increase the pressure 2 times at the input side, the sensor output should also increase 2 times. Then it will be better for you, for example. Okay, so that is the linear.
So dynamic range. So what is that?
Dynamic range. What is the maximum value it can produce for a given input signal? Means upper range and lower range. Means lower range means suppose you are giving smallest amount of input pressure, then there should be some voltage value corresponding to that pressure in case of pressure sensor. And suppose some highest value of pressure is there. Okay, so for highest value you are getting another voltage for that. The difference between the highest value of the output and the lowest value of the output of the signal is called dynamic range. Okay. So for small change, actually dynamic range depends on the constant terms. In case of linear relationship between input and output, I told you that is y is equal to mx is a relationship, linear relationship. If the value of m is high, then dynamic range will be large. Okay. So small change of input signal will give higher change of output signal. That will increase the dynamic range and sensitivity. Okay. And resolution also will increase somehow due to this one. And noise produced, uh, different types of noise components may be generated at the output. So that is another factor. The sensor will use different types of circuits also. Okay. And these circuit components may generate some thermal noise and other types of noise, short noise and other types of noise. This noise should be very, very small for a particular type of sensor. For example, in camera, okay, if you try to increase the resolution of the camera, means number of pixels of the camera, or you can say that if you want to reduce the size of the pixel for a camera, then automatically to cover a particular geometric area, the number of pixels will increase. And in that case, actually, in the camera sensor, you have to increase the number of array elements. So you cannot increase the number of array elements unlimitedly. Okay, you will see that after a certain range, if you want to increase the number of elements within a given area, then a particular type of noise is increasing at the output. Whenever you are capturing the image, then a particular noise is coming. That is called short noise. Okay. So how much noise it can tolerate, your sensor can tolerate or can produce, that should be also another factor that should be mentioned in the specification. Okay. The sensor specifications, I have given a few specifications. Different types of sensors for different applications, they may have different specifications. You can get it from internet. Okay. So here just I am giving some examples of some sensors here. This is acceleration sensor. Okay. And a small description I have given. This figure shows a small sensor manufactured using microsystem technology. The sensor contains small mass in the center here. Small mass is there. Okay. When the system is accelerated, then the mass will be displaced from its standard position, and one wire is connected with this mass, and when the mass will be displaced from its standard position, then due to this displacement, the value of the resistance will change, and when the value of the resistance will change, then the voltage across the resistance will also change. Therefore, it will measure the existence of acceleration. It can sense the acceleration, whether acceleration is there or not. When it is uniform velocity, when the system is in uniform velocity, then this mass will not change its position. Okay, so in that case, the resistance value will be constant, and it will not show any change of voltage at the output. That means I want to say that the acceleration, this particular physical quantity, is converted to a voltage, and this voltage will be collected for processing. Okay, so this is one acceleration sensor. Similarly, rain sensor is there. So here you see, in order to remove this distraction from drivers, some recent high-end cars contains rain sensors. Okay, so what is rain sensor actually? What is the basic principle of this rain sensor? I have written here. You can see that here after sensing the rain or an amount of rain, it can adjust the motion speed of the wipers. So when the rain is very small, the speed of wipers may be means smaller, and when the rain is increasing, then more and more water is falling on the glass of your car, and then it is required to speed up the wiper. It can be automatically controlled after sensing the rain by a sensor. Okay. The rain sensor works on the principle of total internal reflection. In the infrared, an infrared light beams at an angle of 25-degree angle on a clear area of the windshield from the sensor inside the car. One arrangement is there. Okay. So it is not possible to draw all these things here. So at 45 degrees, some light beams will fall after reflection. Okay, after reflection on the glass surface. Then this reflected back signal will be sensed by a sensor, light sensor. When rain will fall on that part of the glass, then automatically most of the light will be scattered in different directions, and lesser amount of light will reach at the sensor, and the sensor output will generate lesser amount of voltage. So in indicating that there is a rainfall. So rain is falling on the glass. So this is the basic principle. Okay. So based on this, rain sensor works. Another sensor is image sensor. You know, generally we use these are the two widely used image sensors: CCD, charge coupled devices, and CMOS sensors. Okay, this charge coupled device sensors, this is old one, but this till now this is used for high-end camera. But recently, actually, CMOS camera has come into the current technology, and the cost of this CMOS based sensors are very small with respect to the CCD cost, and at the same time, it is possible to get this CMOS sensor in compact form using the technology of integrated circuit. So
What
We
is the
can
CMOS?
use, yes.
So what is the full form of CMOS, sir?
What is the CMOS
Full
means?
form.
You don't know CMOS, metal oxide semiconductor, complementary metal oxide semiconductor.
No, sir. I knew MOS, sir, because metal oxide MOSFET.
Okay, CMOS is one kind of MOS. CMOS, PMOS, NMOS, different types of MOS. Metal oxide semiconductors are there. So it is not possible to discuss all these MOS types here. Just I am mentioning, if you are interested to get more and more information about CMOS, you can consult with any electronic books of indicator circuits. VLSI, VLSI book you can follow for getting how this CMOS can be uh, obtained in integrated circuit form. Okay. And in charge coupled device, actually, what is done, uh, the charges are transferred from one pixel to the next pixel until it can finally read out at an array boundary. So it will go from left side to right side, and right side some boundary is there, for example, and the charge will flow from left side capacitor to right side capacitor within the CMOS CCD. Charge couple. This is also uses some um, type of IC mechanism, IC fabrication mechanism, and in the here actually uh, in the uh, silicon substrate, uh, different uh, capacitors are fabricated. Okay, and these capacitors will means when light fall on this, some photodiodes are there, green photodiodes here is written, and based on this uh, light intensity value, the charge will be stored in the capacitance, and then it will flow from one capacitor to another capacitor. Uh, okay, uh, so this particular technique is utilized here for storing the image information. Okay, so it will actually store the charges. Okay, and the amount of charge will be dependent on the light intensity. Then again, these charges will be taken as a voltage, and it will be amplified by amplifier. Then the right hand side, this amplifier is given. Okay, so I am not giving the details internal structure for charge coupled devices, because if I want to give it, then I need at least 4 classes for this only. Okay, that's why I am giving just the outline of the charge coupled device. If you are interested to know more about this, then obviously you can follow some books of image sensor. There, the details of charge coupled devices. Okay, so that is a particular subject, image sensor. Okay. However, what I want to say, uh, that this kind of sequential charge, actually, why it is called charge coupled device? The charge from uh, one capacitor is coupled to another capacitor in a particular manner, and that's why it is called charge coupled device. So the sequential charge transfer uh, gives this name, charge coupled device. And the image that is produced or that is reconstructed by from this charge coupled device, once generated by this charge coupled device, is this quality is very high with respect to CMOS. But nowadays, actually, CMOS technology is also growing, and the quality of uh, image output from CMOS also is nowadays enhancing. Okay, so this is charge coupled device, and then CMOS sensors are also there, and the architecture of CMOS sensor arrays is similar to the standard memories, just like CMOS memory array is there. So in your digital class, I think you have studied this memory area, how memory is fabricated there. So uh, now you see, uh, using CMOS technology, actually, an array of memory uh, type thing is formed there. And memory means actually it will store the charge. Okay. So it will store the charge. How the charge will be stored in the capacitance in the CMOS? Again, some means uh, light will fall on this, and as per this light intensity value, actually the charge will be stored there, and then we can read this stored voltage, and then I can sample all these means voltage values, and then I can uh, send it to display unit for displaying the output. So it will give the image. Okay. Now, since this CMOS circuit is available in integrated circuit form, in compact form, and uh, you can at the same time with the sensor, CMOS sensor, you can design some logic circuit within the same chip which can process the signal captured by the CMOS sensor. So within the same chip, it is possible to capture the signal and process the signal. That means it is becoming more and more compact. That's why nowadays different uh, handheld uh, small cameras, they are using CMOS technologies. This camera means I want to say this um uh, webcam or this type of mobile camera and computers webcam. All these things are actually using CMOS technology, CMOS sensors nowadays. But for high-end camera, actually, means high-end means for higher quality. Till now, CCD cameras are used. But what I want to say, mm, uh, in earlier days, actually, for this kind of small cameras, also you used to use uh, CCD, but those CCDs are replaced by CMOS sensors. Okay, so CCD versus CMOS sensors, so advantage and disadvantages we have written. You can read it. Then biometric sensors. Sometimes it is required to know. We need some biometric. Sometimes actually what I need some security. Okay, I think most of the uh, latest computers, they are using biometric for for the security. Okay, for means open your computer, for closing your computers, like this. Okay, so biometric means, for example, fingerprint is one biometric. Okay, iris is another biometric, your face is another biometric. So biometric may be different types of biometric may be there. Okay, so here you can use some fingerprint for means I want to say for unlocking your mobile or unlocking your uh, computer. Okay, so there obviously some sensor is used which will take your biometric and it will be converted to a digital data. So the pattern will be stored there, and whenever someone will use your his biometric to open, then if that biometric is not means uh, compatible to that biometric, means if that is not equal to that biometric, then it will not open. Okay, so this kind of biometric sensor can be used for authentication. Okay, but obviously biometric is not so secured because your biometric information may be stolen by some person and it can be used for breaking your mobile or computer. So it is not so. Um, and sometimes another problem is also there. Uh, Whenever your biometric is stored for your reference, at that time you have put your finger, for example, in case of a fingerprint, you have put your finger in a particular position, in a particular means shape, yeah, particular angle. Okay, so that data is stored there. But then, if it is locked, if you want to open that using biometric, by using your biometric signal, biometric fingerprint, then in the second time, at the time of opening, if your angle is different, then it will not open always. It may create problem at the time of opening. So you have to put at the same angle, then automatically it will be easily analyzed and it will be then open. Okay. Otherwise, you have to try again and again, 3 times, 4 times, 5 times for opening the computer, for unlocking your computer or your mobile. Okay. So this kind of problems may occur if you use biometric sensors. However, biometric sensors are used nowadays in different areas. Okay, these are the limitations. I already mentioned this. Then artificial eyes are also there. Okay, artificial eyes means actually what can you do? What you can do? You can means in place of your eye, actually some camera systems may be used. For example, 2 cameras may be used on the 2 glasses of your spectacle. Okay, so the camera will capture the front view, and then based on that view, based on that captured information, video information, this you can take decision of what will be the actually basis mechanism. I want to discuss that. Suppose these 2 cameras are taking the video, then this video will be sent to the computer. The computer will analyze. The computer means actually the computer will be a small computer that can be installed in your head. Okay, that can be installed in your body also. Okay, either on your head or on your body. So that will be analyzed, and then analyzed means actually which particular object is at what distance, that can be decided by analyzing the video signal. Okay, so after getting this information, okay, the computer will generate some new signal which can be sent to your brain by using leads. Leads means actually uh, different types of electrodes are there. Okay, these electrodes are used for sending the signal to your brain. Some electrodes will be connected to your brain, uh, and the signal that will be generated by the computer, that will be sent to your brain, and then based on that you can take decision. Okay, so it was tested actually. It was tested in 2003. Okay, and it was seen that uh, if the computer takes some image, so for example 128 by 128 type, there's this size of image by a camera, then based on the analysis of this image, uh, it is seen that some persons, they were able to drive the car, they were able to see the front scene, and they were able to drive the car in some controlled areas. Okay, so this is artificial eye, and other types of sensors are there. It is not possible to discuss all types of sensors. That means pressure sensors are there, proximity sensors are there, engine control sensors are there, Hall effect sensors are there, and many more sensors are there. So these are the basic sensors which are widely used in different applications. And the image sensor is the most important sensor, because most of the time uh, we want to get the image information for processing the signal to take the decision about the environment. Okay, so image sensor is very important. Also temperature sensor, this is also important. So different types of physical quantity we may have to sense at different times for different applications. So for different types of physical quantities, you can use different types of sensors. Okay. Anyway, so this is the first part of our discussion. So in this part, actually, we have discussed about a closed loop systems and different parts of the systems in briefs, different blocks of the system in brief. Then we have actually discussed about some widely used sensors, which are generally used in different systems. Okay, sensors. And if you want to know about more and more sensors, you can use any book for sensor design. There are different types of sensors are discussed, but for this embedded system, uh, means I want to say syllabus, it is this much. Okay. So in the next class, I will discuss whatever signal is obtained from the output of the sensor. That signal should be sampled first, and then it should be converted to digital signal. Therefore, in the next two, 3 classes, I will discuss on this sampling theory and sampling and hold circuit, which will give you the sample values, and then I will go to the circuit for AD conversion, where each and every sample will be collected and it will be converted to digital numbers. Okay. So these parts are the main part which I will take. Okay, thank you. Let me take the
Sir, will you
attendance.
upload the slide, sir?
I will. This slide is not complete. I will give you after completion. Okay. Up to this much, I have just prepared up to this part. I can circulate this slide also, no problem. But what I want to say, okay, I will circulate it. First part you will first read, then I will circulate the second slide. Okay, I will send it to Abhishek. Okay, Abhishek is there.
Yes, sir.
So I will give it to you. Then you will circulate to your friends.
Yes, sir.
Okay, then obviously for this sampling and AD conversion, I will prepare some slides. It is not prepared till now. Tomorrow, what I will take, I will not use PPT. In board, I will teach you a sampling theorem. Okay. But some PPT prepared, then I will also present in front of you. Anyway. Students are there, but I cannot take the attendance. How? Why? Is there any problem?
না স্যার সাইডে তিনটে ডট আছে ওইটা কি
এটা দিচ্ছি তো কই পেয়েছি ওকে পেয়েছি পেয়েছি ঠিক আছে তাহলে আমরা আজকে শেষ করি
হ্যাঁ স্যার
কালকে আবার আমরা শুরু করব কালকে আমরা কালকে তো ক্লাস ছিল বোধহয় ফার্স্ট হাফ নাকি ওটা সেকেন্ড
হ্যাঁ
হাফে
স্যার
নিচ্ছি ওটা
হ্যাঁ
এই দিস টাইম ওকে এই টাইমেই নেব
হ্যাঁ
ঠিক
থ্যাংক
আছে
ইউ স্যার
Thank you, sir.
থ্যাংক ইউ স্যার